first glance, it's hard to tell what's happening with all of these moving parts.
We have a large project between the Barton Springs Edwards Aquifer Conservation District and other agencies and other conservation districts to better understand the Trinity aquifers, within Hayes County and Travis County and even other counties beyond. So we've been connecting up 10-foot sections, 5-foot sections, and packers with couplings. Most of these just regular couplings that just connect one piece to the other, but certain couplings actually have a function for monitoring.
One by one, each piece comes together to form a multi-port monitor well here on this property in Hayes County, owned by the Wimberley Valley Watershed Association.
We're in the process of installing 2 monitor wells in the vicinity of Jacob's Well, one of which is a multi-port monitor well. It's a very sophisticated type of well that allows you to monitor multiple zones in a single borehole.
Data collected from the well will help the district monitor the middle and lower Trinity aquifers.
This area has experienced a lot of growth, heavy demand on the groundwater. There's really no surface water available around here, so everybody's on groundwater, and they're getting it somewhere largely from the Trinity aquifers. So we're trying to understand these aquifers better. We're trying to understand how flow goes from the aquifers to Jacob's Well, which then feeds into Cypress Creek and ultimately the Blanco River. So Jacob's Well is very important to people live around here, people downstream from here. Water coming out in Jacob's Well can actually recharge the Edwards Aquifer further downstream.
We have 6 other multi-port monitoring wells throughout the district that provide us with an abundance of information on what's happening with the Edwards and Trinity Aquifers. Components for the multi-port well are provided by Westbay Instruments based in Vancouver, Canada. Installing the monitor well is a tedious process. Before the installation began, the well was designed based on well logs and geology.
We have measurement ports from which you can measure pressures in the aquifer and you can collect samples. And we have pumping ports which you can open up and actually do hydraulic conductivity testing. So when we lay this out, we design the well based on the well logs and our knowledge of the geology. And then we start putting it together based on, where we want the packers to go, because the packers separate monitoring zones. Between 2 packers, we'll have various sections of casing with a measurement port and a pumping port. And that makes a complete Westbay monitoring zone.
And while this all looks complicated, the job of the multi-port well is quite simple. It will look at 9 monitoring points.
So what we're looking at doing is monitoring, say on this figure here, we're going down. The bottom of the well is about a depth of 540 feet into the Hostin Formation, which is lower Trinity and largely a sand unit. And above that is the Sligo Formation, also lower Trinity and more of a limestone. Then we have the Hammett Shale in here, which is a sealing unit that seals off vertical movement of water between the lower Trinity and the middle Trinity. So the key units of the middle Trinity are the Cow Creek, Hensel, and part of the lower Glen Rose. So we'll be installing packers that separate these zones, and we have 9 of them. So we have one zone to be Hostin, one that'll be Sligo, one that's Hammett. We're going to break into Cow Creek into 2 zones, the Hensel into 2, and we're putting 2 zones into the lower Glen Rose. So we can better understand the relationship vertically of how water might be moving or actually not moving between these different units.
Here's a look at what an entire monitoring zone looks like after it's put together.
This is how these different pieces of the multi-port monitor well look and how they function. This actually constitutes an entire monitoring zone. These zones could be as thin as about 3 feet. They could be 100 feet or more thick, depending on where you want to monitor and where you want to install packers. So to start with, we have a borehole that could be 4 to 5 inches in diameter, and then we design where we want to seal off different units, and we install packers there, because a packer essentially inflates into the borehole. So this swells up like a balloon, so it prevents water from moving above to below or below to above, and we'll have another packer down below. So that seals it off as an individual monitoring zone. Then within that, we have 2 key components, one of which is a measurement port. This was the measurement port from which we take pressure measurements, and we also collect samples from this. And we have a pumping port down here, which you can actually open and close with a special device that we lower down. So in that case, it'd be open with a screen, so we can close it, and we do hydraulic conductivity testing, basically slug test in that.
But it's the measurement component that serves as the key feature.
But getting back to the measurement port, this is really the key feature, because we have a valve in here. There's a tiny little pinhole valve. I'll pull this tool out. So if you look down here, this little metal bead right here is a valve that allows water to move in and out when this is pushed open, it's spring loaded. So we have this device that comes down. This is sort of the measuring tool and also the sampling tool. It goes down in there, and we need this little point here to line up exactly with that other point down in the well. And that might be 100 feet down, it could be 1,000 feet down or more. They have to line up perfectly, but the system is designed for that to meet with that other point. And then we have connection from the formation out here to a pressure transducer in here, so we can measure pressures and determine potentiometric pressures in the aquifer. Then we can also pull a sample by opening a valve, letting water flow in, and it can flow down into some sample bottles. But we lower this from the very top and say we're just doing this one zone here. So as we lower this down, it comes down as we see it getting close to that port, and this is what needs to line up here. So that needs to turn over there just a little bit, and then we lower it down, and then that will catch. And see how it rotates? So it catches at an exact point where these two valves are lined up perfectly. And then we open a little motor that this backing shoe pushes here, so that pushes against the side, and at that point that valve is open and we have connection from our pressure transducer inside to the formation pressure outside.
The information gathered from the district's monitoring wells helps us make decisions when it comes to preserving and protecting groundwater and our aquifers.
We need to do the science to really understand how these aquifers function and what happens when we have high rates of pumping and if we have drought. We know, well, that'll cause water levels to get lower, spring flow will be less, but how much less is the question. We need to make sure that we always have water available for people that need it for drinking water purposes, other commercial, industrial purposes, and yet we have to protect the ecology, where there's endangered species, or we have a lot of recreation in the area, referring from Barton Springs to Jacobs Well, the Blanco River, Cypress Creek. So this is the focus of our studies, and such that our district and our board of directors can set policy that makes rules that help protect these aquifers. So that's why we're doing all these studies, to better understand the system we're dealing with and how can we put rules in place that are meaningful rules and can be substantiated with good science.